Hello, Assalamu alaikum. So today we are going to discuss the last two properties of the circle, and this one is about the intersecting chords. Now we can see there are two circles in which there are two chords. For example, if I'm talking about the first one, so what is going on in the first one, we can see that there are two chords. One is AB. If I highlight this one, the first chord is AB, and the second chord is CD, and they are intersecting at point P. Right, so these two theorems are regarding the chords which are intersecting each other. And similarly, if I see the other one, they are interrelated to each other. If I see the other one, in this one there are two chords. Again, A to P, this is a chord, and again C to P is again it's a chord, and they are intersecting. But the only difference is that in the first case they are intersecting inside the circle, and in the second case they are intersecting outside the circle. So we are going to analyze these two circles separately. So this theorem says as if there are two chords which are intersecting inside the circle, and it means that they get divided in some parts. Now, for example, if I say that this part is, let me mark it. If I say that this part is, for example, 2 centimeters, and if I say that this one is 6 centimeters, so a chord AB after intersection is divided into two parts. One is 2 centimeter and the other is 6 centimeter. Similarly, if I see the side CD and if I mark it as that it has been divided into two parts, for example, it's 4 centimeter, and the other part, for example, this one is 3 centimeters. So what does this theorem states? This theorem says that these two parts, if we take the product of the parts, they will be same if they are intersecting inside the circle. For example, if I take the product of the first two parts, that is 2 times 6, and if I take the product of the other two parts, for example 4 times 3, so it says that in both the cases the overall length will remain the same after taking the product. This is the case in which the chords are intersecting inside the circle. Now let's analyze the second diagram in which the chords are there but they are intersecting outside the circle. Now again, this theorem states that if they are intersecting outside the circle, the only difference would be that if, for example, the total length here is 10 centimeters, and let's say the outer length means the part of the length which is outside the circle of the chord is, let's say, 3 centimeters, for example, like this. Right, similarly it says that on the other side, if the total length, for example, let's say is 6 centimeter, for example, and let's say this outer length which is outside the circle is 5 centimeter. So again, this theorem says that if you take the product of the whole length of any chord, for example A to P, which is 10 centimeter, and you times it by the length of the chord which is outside the circle, for example in the first case is 3 centimeters, this should be equal to the second chord which is the total length 6 times the outer length. So 10 times 3 is 30, 6 5 is 30 centimeters. So this theorem says that the outer length times the total length of the chord should be equal of both the chords if they are intersecting outside the circle. This theorem is known as the intersecting chords theorem.